Hello, welcome to a short video on how to run a two-way within subjects ANOVA in SPSS. So as you'll see, to start with, I've set up the data appropriately for a two-way within subjects ANOVA. So what this means is I have two independent variables or two factors. So in this case I have factor 1 identified by F1 here and factor 2 identified by F2 here. Now in this case each of my factors has two levels. So factor 1 has level 1 and level 2, and factor 2 has level 1, this one here and this one here, and level 2 here and here. In a two-way repeated measures, or in any two-way ANOVA, we can have more than two levels of any factor, but this type of analysis we've just got two, so this will be a 2 by 2 within subjects ANOVA, or sometimes known as a 2 by 2 fully repeated measures ANOVA. With within subjects ANOVAs, repeated measures, in particular fully repeated measures, it's very important to get the factor labels correct. So what this means, because everybody takes part in every condition, you have an individual, say participant 1, who has a score when they are in condition or factor level 1 of factor 1 and level 1 of factor 2. They also have a score of when they're in level 1 of factor 1 but level 2 of factor 2, a score of when they're in level 2 of factor 1 and level 1 of factor 2, and a score when they're in level 2 of factor 1 and level 2 of factor 2. So if we can imagine a specific example, say they're trying to learn memorize a list, and they try and do that quietly or with noise. So say factor 1 was quiet versus with noise, and they did it in the morning and in the afternoon. What we'd end up with is they would take part, in this case, factor 1 level 1 quietly, factor 2 level 1 in the morning. This one would be factor 1 level 1 quietly, factor 2 level 2 in the afternoon. This one would be factor 1 level 2 with noise, factor 2 level 1 in the morning. And this one, factor 1 level 2 with noise, factor 2 level 2 in the afternoon. So each participant has taken part in all of the conditions of the study, and they've had to make sure that each that these have probably been fully randomized. So these may have taken part in a different order to eliminate any order effects. So that's how you would set up your data. You would probably label your factors according to the variables that are of interest to you. I've just labelled like this so you can see the relationships between those factors and the levels. Now to run the analysis, we would click on Analyze, General Linear Model, Repeated Measures. We would assume we've tested the data prior to this for its assumptions in terms of normal distribution and in terms of making sure that the data were at least interval. So when we click on Repeated Measures, it will ask for our within subjects factors first of all. So in this case I'm just going to call my first factor IV1, so that could be the independent variable, could be noise versus no noise, and that has two levels. Because I have a second independent variable or factor, I'm going to call this IV2, that also happens to have two levels. They don't have to have the same number of levels. You could have a 2 by 3 or a 3 by 2 or a 4 by 2, etc. And if we wanted to make a three-way ANOVA, we would therefore add an extra variable here and the number of levels. Obviously it gets quite complicated in terms of the data setup to ensure that each participant has the appropriate data under each of those levels. So this is a 2 by 2 design. So this is also where it can get tricky, and it's important to ensure that both you've labelled your factors correctly and that you move them in the correct way. So these need to be specifically put in this order. So it suggests here IV1, so we need to have IV1 level 1, IV1 level 1. This one should be IV1 level 1 and IV2 level 1 as denoted by that 1, 1. So I've called these factor here, factor 1 level 1 and factor 2 level 1, so I'm going to put that one there. This one should be factor 1 level 1, so in this case again the example I gave was with, say, in silence, and then factor 2 level 2, so that would be the afternoon. So factor 1 level 1, factor 2 level 2. Now we're into factor 1 level 2, so factor 1 IV1 level 2, so that is, say, with noise or in silence, whichever is the opposite. and factor 2 level 1. So that one will be moved across. And lastly, factor 1 level 2 and factor 2 level 2. So mine happened to be in the order that they were put in, but they didn't need to be, and they may not be in your design. So all the variables have been put in. We do not have a between subjects factor. If you were looking for, if we had a between subjects factor, that would make it a mixed design. So I'd like to run some options just so I get some means, so I can see here to try and understand my effects. What we'll see here in terms of our effects, we have a main effect, and we'll be looking for a main effect of factor 1, a main effect of factor 2, and the interaction effect between factors 1 and factor 2 is denoted here as IV1, IV2. Descriptive statistics and estimates of effect size are always useful. I'll also put a plot in there. So I don't know what the results will be, so I'll put IV1 along the horizontal axis with IV2 or factor 2 as separate lines and add that, and then produce the opposite. Have IV2 as along the horizontal axis and IV1 as separate lines. And then I'll look at both of those and work out which of the representations I feel is an easier way to understand the data. So when I've set that up, I'll click on OK. So first of all, it demonstrates what I've set up in the data, and this is a useful way to check where you put the data in correctly. So this should be IV1 level 1, so in this case factor 1 level 1, which it is for both of those, and factor 1, IV2 level 1, which it is here, and IV2 level 2, which it is here. In this case this is IV1 level 2, which it is for these two, and then IV2 levels 1 and 2, which it is here. So again, it's important to double check this. There are some means for each of my variables. You can see means and standard deviations and number of participants. We're not so interested in the multivariate tests here. Morsley's test of sphericity is important if we have, it's very important in within subjects repeated measure designs, but mostly important, it's only relevant if we have more than 2 levels of any one of our factors or independent variables, which we don't in this case, which is why there are dots here. If there were more than 2 levels, we would need to check whether sphericity has been violated. If it has, we would need to do some corrections here. So these scores are when sphericity is violated, but it isn't in this case because we only have 2 levels, so we can delete all of those violations of sphericity corrections and just leave the sphericity assumed row. So as it's fully within, we only have within subjects effects, so we don't need that between subjects effects. We can delete that. So this is looking the effect of IV1, and what we notice here is that is significant. So we have a significant effect of IV1, so there is a difference between level 1 and level 2 of the first independent variable. We also can look across to our main effect of IV2, which also is significant in this case and shows a larger effect. Again, we need to be cautious about using partial literature squared in within subjects, but for the moment this just demonstrates notions of effect size in addition to understanding significance. So there is a main effect of IV2, and then if we look at the interaction effect, it looks like there is no interaction effect. So here we have our 2 main effects and interaction effects. These 2 are significant and this one isn't. So IV1, we can now look at our mean scores for IV1 level 1 and IV1 level 2. So we can see here level 2 is higher than level 1, and because there's only 2 variables, we know this is a significant difference. Then if we look down for our other main effect of IV2, you can see here there's level 1 and level 2 of IV2, and this shows there is a significant effect, with IV2 level 2 being higher than IV2 level 1. So if we use the example of noise, no noise, and morning and afternoon, what this might demonstrate is that if level 2 was with noise or in quiet, whichever way around we had it, that was significantly higher than the other one. And if this was more in the afternoon, there would be a significant impact of, memorizing more in the afternoon than in the morning. But there's no interaction effect. What this seems to suggest is therefore that the afternoon is always better than the morning, and under noise conditions is always better than under silence, or vice versa. And there's no interaction. And interaction would mean that maybe silence is better in the afternoon but noise is better in the morning, those interaction type effects. Look at the profile plots. We can see here there's a higher score on IV2 level 2, which is this one here, than level 1, and you can see that the lines are rising up, which means there's a higher score for IV1 level 2 here as well. I think that is a good way to represent the data. Similar things shown here, so because it's two main effects, you get the lines parallel and they are moved away from horizontal, and so actually either of those would demonstrate quite clearly the result. Okay, hopefully that's explained a two-way within subjects or repeated measures ANOVA.